Hello students, I am Rahmat Ali from Indirapuram Public School. In our last lecture, we discussed about friction and some methods of changing force of friction. Today, we will do circular motion, banking of roads and some examples based on that. Circular motion. We know when an object is moving on a circular path, then it requires centripetal force. If a body of mass m is moving on a circular path of radius r with velocity v, then it requires some centripetal force F equals to mv square upon r. This force is always directed towards the center. As we know, forces always exist in pair, so there should be another force which should be in the opposite direction of this centripetal force. That force is called centrifugal force. This force always acts outward away from the center. For looping the loop, centripetal force and centrifugal force have to be equal. Bending of a cyclist. Let a person of mass m is moving with velocity v. He has to take a turn on curved path of radius r. In order to obtain centripetal force, he has to bend his body in the inward direction of the turn. Let he bends it at an angle theta with the vertical direction. The normal reaction offered by the ground to the cyclist is r. This r is inclined at an angle theta with the vertical. Resolving r into its components, we get r cos theta along the upward direction, which balances weight of the body which is in the downward direction. So, r cos theta equals to mg, and the second component r sin theta is towards the center, which provides the necessary centripetal force. So, r sin theta is equal to mv square upon r. Dividing both the equations, we get r sin theta upon r cos theta is equal to mv square upon r divided by mg. Cancelling r from left hand side and m in the right hand side, we get tan theta in the left hand side is equal to v square upon rg. Using this relation, we can calculate angle theta at which a cyclist has to bend his body while taking a turn. Now, we will discuss motion of a car on a level curved road. Let a car of mass m is moving on a circular path of radius r with velocity v. As car cannot bend, then how it obtained the centripetal force? Centripetal force required will be mv square upon r. Due to the absence of source of centripetal force, this car will tend to skid outward. So, the force of friction will be in the inward direction. Normal reaction offered by the ground to the car is r equals to mg. Force of friction is F. So, F equals to mu into r, F equals to mu into mg. For safe turning, this force of friction which is acting in the inward direction, that should be greater than the centripetal force. So, mu mg should be greater than mv square upon r. Cancelling m from both the sides, we get the minimum velocity for safe turning v is equal to under the root mu r into g. Depending upon the radius of the road, we can calculate the velocity, and for safe velocity some hoardings can be displayed on the roadside. But in real life, we have observed very less drivers are taking care of these signboards. So, in order to increase safe velocity, scientists have discovered a method, and that is banking of the road. Banking of road is the phenomena of rising the outer edge of the road at some angle. This is done in order to increase safe velocity of turn. If road is bent at an angle theta, radius of the path is r, mass of the body is m, velocity of the body is v, then centrifugal force F equals to mv square upon r, which is acting in the outward direction. So, force of friction has to be along the surface in the inward direction. The normal reaction offered by the ground is r. If we resolve this normal reaction into its rectangular components, we get r cos theta, it is acting vertically upward, r sin theta, it is acting along the x axis, weight mg, it is acting vertically downward, f cos theta, this we obtained by resolving the force of friction into its rectangular components, and this f cos theta is acting along the positive x axis, f sin theta, it will be acting in the negative y axis, mv square upon r is acting in the outward direction. Pointing all these forces on the free body diagram acting at a single point, we get the situation, and at equilibrium net force along x axis is 0. So, that is f x is equal to 0. Substituting all the values, we get r sin theta plus f cos theta is equal to mv square upon r. Say this is equation number 1. Similarly, as equilibrium is along y axis also, so net force along y axis, say f y is equal to 0. Substituting its value, we get r cos theta plus f sin theta is equal to mg. So, this is equation number 2. We know F force of friction is equal to mu into r. Here r is the normal reaction. Substituting these values in equation number 1 and 2, we get r sin theta plus mu r cos theta is equal to mv square upon r. Taking out r common, we get sin theta plus mu cos theta into r is equal to mv square upon r. See, this is equation number 3. From equation number 2, we get r cos theta plus mu into r sin theta is equal to mg. Taking out r common, we get cos theta plus mu sin theta into r is equal to mg. See, this is equation number 4. If we divide equation number 3 by equation number 4, we get v square is equal to rg sin theta plus mu cos theta divided by cos theta plus mu sin theta. Taking out cos theta common from numerator and denominator, we get v square is equal to rg cos theta bracket tan theta plus mu divided by 1 plus mu tan theta. Cos theta will cancelled out from numerator and the denominator. So, we will get v square is equal to rg tan theta plus mu divided by 1 plus mu tan theta. So, the velocity v is equal to under the root rg tan theta plus mu divided by 1 plus mu tan theta. In this relation, by substituting value of radius and theta, we can calculate maximum velocity for safe turning on a given road. If force of friction is not available, in that case we will have to substitute mu equals to 0. So, we get the maximum velocity v is equal to under the root rg tan theta. Free body diagram. To solve numericals in mechanics, it is important to know how to draw free body diagram. Let V have a body of mass m kept on an inclined plane. Weight mg will be acting in the vertically downward direction. Force of friction will be acting in the upward direction if body is supposed to slide in the downward direction. Normal reaction R will be acting in the upward direction, perpendicular to the plane. Resolving weight mg into its rectangular components, we get mg sin theta parallel to the plane in the downward direction, mg cos theta perpendicular to the plane in the downward direction. At equilibrium, mg sin theta acting in the downward direction will be equal to the force of friction F, and mg cos theta will be equal to the normal reaction R. Now, we can use the laws of motion in order to simplify the situation. Today, we have learned about circular motion, bending of a cyclist, banking of road. In the next lecture, you will learn about work, energy, different types of energy, power associated to the situation, and some numericals based on it. That's all for today. Thank you.